All right, number 1. We're supposed to go through and find the measure of each angle. We have 1, 2, 3, and 4 to find the angle measures of. So let's start with Ethan. Ethan, number 1. What angle measure? Why would you want to say that? Okay, going off 110. 110's obtuse, right?
Yes.
And this one's obviously smaller, so I'm glad you recognize that. But let's subtract it from 180 instead of just guessing the distance. In the relationship between them, subtract it from 180 and we get what? 70 for 1. Okay, so angle 1 is 70. Attica, what's angle 2? Yep. Angle 2 is 110. When you have another obtuse angle in this diagram, it's going to be equal to that 110 if these lines are parallel here. So this is also 110. Angle 3, Cody, is what? It's 70. Good. Yep, it's another acute angle, so it's 70. And Jordan, angle 4?
70 also.
Is also 70. Good. All right. The next 4 problems, they should go quick. We're just looking at how they're named. Remember, the position of the letter in the name is how we're going to know what is congruent. Solution, what's congruent to PC?
DL.
DL. Good. DL, put the little segment over the top of it, the little line. Number 6, Gunner, is what? Angle A. Good. Yep, both of them in the middle on the name. Josie, you're up. Number 7.
Angle DLH.
DLH. So it was PCA. So it was the first, the last, and the middle. So you do the first, the last, and the middle on that one. Good. Levi.
APC.
APC. Just have to rearrange those letters. APC in the same order as what DHL was rearranged to get HDL. All right, then the last 3. We got 3 more people. Perfect. It says to write a congruent statement for each pair of triangles and explain why the triangles are congruent. Jamie, number 9, why are they congruent?
I put SAS.
SAS is correct. SAS. Now when it says to write a triangle congruent statement, it's wanting you to make sure that you name the letters in the correct order. So like if I said K and P, you would say that is congruent to. And then since I started with K, I'd have to start with L on this one and make sure that you name them in the right order. Okay, that's what it's talking about. It says a triangle congruent statement. Oh, you can't even see what I'm doing. Let's focus on why the triangles are congruent though for the last 2. Trey, number 10, why are those triangles congruent? AAS. Good. They've got this here in the middle. Same as number 9. They have vertical angles there in the middle, making it AAS.
Okay, on that, does it matter if you go AAS or SAA?
I've never seen it written SAA.
Oh, okay, I was just making sure. I had AAS. I didn't know if it mattered. Okay.
I mean, I wouldn't count it wrong, I don't think, but they always put AAS.
Okay.
I don't know. Nobody's ever asked me that either, so you just want to be difficult.
Well, I just want to, like, if it's on the
Just trying to be difficult.
ACT, you know, both options are there.
They won't put both options.
Okay.
Number 11, Logan. SAS. Which angles are congruent? Are you just guessing? What about the side that they share? Now what is it? No, why are the triangles congruent? We have 3 sides, side. Good. Yeah, we can't just guess that an angle is congruent, although we tend to like to do that. A lot of you like to make those kind of assumptions. We can't make that assumption. So it's going to be SSS. I mean, in all technicality, you are correct. H ends up being congruent to B. Once we know that the 3 sides are congruent and the triangles are congruent, all the corresponding parts of congruent triangles are congruent. So you could argue that you are correct, Logan. We just don't know that by the picture yet. All right, today we're gonna talk about proving triangles similar. So these last three, that was proving triangles are congruent. Those 3-letter ones, that's how we proved that triangles were congruent. Now we're talking about how we prove that triangles are similar. We can prove triangles are similar with just 2 angles. Because if 2 angles of a triangle are congruent, then the third angle always has to be congruent also, because of triangles always equal up to 180. If you've got 2 of them that are already congruent, the third one's also going to be equal. And to show that triangles are similar, all you need to know is that the angles are congruent. Okay, the sides are proportionate, the angles are congruent. So with just 2 angles being congruent on a triangle, we can tell that the triangles are similar. Remember, they use just this one little squiggle to say that the triangles are similar instead of congruent. They're not equal to each other. They're going to be the same shape, just a different size. Okay, so like on this one, it says, do you know that these triangles are similar? And because we have vertical angles right here in the middle, we could say yes. And the reason would be angle similarity. They use this little squiggle on there to show it. Angle similarity. We have 2 45-degree angles and then vertical angles here. Another type of problem, look at B. Do we know that those 2 triangles are similar?
No.
We have 70 and 70. We'd have to check and see if those other angles are congruent. And to do that, you would add, say, 30 and 70 is 100. Subtract from 180, and we get 80 degrees for this one. So since that one's 85 and this one's 80, that would be no. It says, how do you know? We showed the math for it. Okay, 80 is not the same as 85. All the angles have to be congruent for the triangles to be similar. We just have to show that 2 of them are though, and then by default, we know the third one is. So look at number 1, A and B here, and write down whether you think they are or are not similar. Okay, I'm gonna have you take a moment to look at those. You can discuss it with someone else if you're still not feeling confident. Try those for just a second. B is a little bit tricky. We probably need to talk about it. All right, so I'm gonna unfreeze it. We're gonna talk about A first. I worked out A down here below. First thing I did was I added 39 and 90. When I added 39 and 90, that gave me 129. Then I subtracted that from 180 to see what this other angle measure was. And when you subtract 129 from 180, you get 51. Doesn't really look like a 51, but that's a 51. So that one is a yes by angle similarity, because you'd have 51 and 51, and then the 90 and the 90. On part B, they mark these triangles as isosceles, which tells me that the base angles are congruent. When we talked about isosceles triangles, remember that? So both of these are 68. Basically, we need to see either if this one would be 62. No, we need 2 angles. So we got to see what these base angles are. Okay, we need to see what those base angles are. So to find those base angles, we would subtract 180 minus 62. And that's going to give me 118, and then divide that by 2 to see what these base angles are. So if you take 118 and divide it by 2, we get 59 degrees for those 2 base angles. So this one would be a no. If that's 59 and 59, that's not going to be congruent or similar to one that has 68 and 68 down here. Okay, so we have angle similarity. So just with two congruent angles, we can tell that triangles are similar. We also have, similar to the congruent triangles, we have side angle side. So if we have two sides in an angle, we can tell that they're similar. On the sides don't have to be congruent. The sides have to be proportionate. Okay, so that's shown here. So you have to check and see, are two of the sides proportionate? And do we have a congruent angle? Then you can tell the triangles are similar. Or do you have three proportionate sides? You can tell that the triangles are similar. Okay, so now we have with just two angles that are congruent, we have two proportionate sides with a congruent angle, or three proportionate sides. We can tell that triangles are similar. So when we look at A, it didn't give me any angle measures. So I know I'm not using angle, or side. I am looking at these sides here. So like we did yesterday, let's match up the corresponding sides. So the two smallest sides are 6 and 9. We want to know, is that the same as, and then check 8 and 12, and check 10 and 15. You can do it with the cross products, or you could simplify those fractions. Calculators will simplify the fractions for you if you use a calculator. Otherwise, you look and you see what will go into both of them. This one reduces by 3. This one will reduce by 4. This one's going to reduce by 5. So we end up with 2/3 and 2/3 and 2/3 again. So those are all equal. And so this one would be yes by side similarity. It does say to write a similarity statement for the triangles. It wants us to do the same thing as when it says to write a congruent statement. It wants us to write the triangle in the correct order, which I used to kind of just skip over when I teach this. Then I realized how hard that is for some people. So we need to practice it. So if they test you on it on the ACT test, you're prepared to answer those. The triangle, let's say STU, is similar to triangle. Now I started with S, I went to T, and then over to U. So I got to go X, V, W to go in the right order. X, V, W. So I went down the short side and then the second shortest side. 8 and 12 went together. 6 and 9 went together. So you gotta make sure you go in the right order. Yeah, we have a help button. When I used to do interactive slides and used to teach up at the board, it actually worked. You push the button and then it'd help you out. And what it did to help you out is it separated the two triangles. So we're gonna separate the two triangles on our own. Okay, let's separate those triangles. We got this little triangle that has 8 and 12 on it. Then we've got a bigger triangle. What are its dimensions? 10 and 15. Good. You see that? What Logan did there? He added the 8 and the 2, and the 12 and the 3 to get 15. Now they share this angle here. So we do have a congruent angle in between those sides. I don't have two angles, so I can't do angle similarity. We're checking to see if side similarity would work. So to check that, you have to check and see if the sides are proportionate. So 8 matches up with 10, 12 matches up with 15. Do those reduce to be the same? Are they equal? You can track it with the cross product and see if the cross product's equal, or you can simplify those fractions. Let's simplify the fraction to stay consistent what we started doing. So 8 over 10 would be 4/5. Reduce both of those by 2. 12 over 15 would reduce by 3, which would also give me 4/5. So the sides are proportionate and they have a congruent angle in between them because they share this angle K. They both have that angle K. So this one would be yes by side similarity. And then it says to write a similarity statement. So this one was K, L, and P. This one was K, M, and N. I'm just going to write them in that order. Triangle, KLP. Oh, I wrote it down. KLP is similar to triangle KMN. I think similar triangles are a little complicated. We like everything just to be equal. It makes it easier when it's just absolutely equal. Now we're talking about whether it's proportionate or not. I think that makes it a little bit tricky. But the new stuff of the lesson has all been taught. Now we're just practicing it and reinforcing what we've already talked about today. So we just need to remember angle similarity, side similarity, and side angle side similarity. And remember that when we talk about those sides, we're talking about those sides being proportionate. Okay, so look at this one. Are those sides proportionate? We only have 3 sides. 6 goes with what?
8.
8, and 9 goes with 12. Are those fractions congruent, basically? Is that a proportion?
Yes.
6/8 reduces to, did you reduce it or did you cross multiply to see?
I reduced
If you reduce it, we get 3/4 on this one. This one you reduce by 3 and you also get 3/4. So this one is yes by side similarity. If we write the similarity statement, we would say triangle ABC is similar to triangle, let's see, I start with A, BC, so let's go with FEG. You guys are doing the long side if I write it with AB first, so FEG. Could I have said EFG? Would it have mattered when those sides are congruent? And the answer is no, it'd been fine. Just make sure you start with the longest side. Separate the 2 triangles on B. Separate them. I want to see if everybody can get them separated right. Separate those 2 triangles. You have the little triangle with 6 and 8. And then what are the dimensions of the big triangle? Get it labeled on your paper. Write the letters on it too. I'm going to come around and check. So make sure you get it done. Don't sit there and wait till I start walking. Go ahead and get it all marked and written down.
What you been doing?
I can't say that to my phone.
I have to say, I'm impressed that you guys are able to separate those triangles and write the correct dimensions. And I know some of you are like, why? That's easy. It's not easy for everybody. I've taught long enough to know that usually students really struggle when they have to separate triangles that are overlapping like that. So if you're understanding it, that's great. If you're not understanding it, that's actually more normal to not get it out. It's hard for students to separate those shapes like that. As I walked around, like most of you already had it done. Like it's just no big deal. That's cool. That's good. Okay, you got a little bit of common sense. That's good. We got 8 and 6 on the first little triangle, which was ALW. Then we have 16, because 8 and 8 was 16, and 6 and 6 makes 12. And that was an A. That kind of looks like an A. A and C and E on those sides. Okay, so we want to see if these triangles are similar. We have the angle in the middle, but just one angle, so I can't use angle similarity. I got to check and see if those sides are proportionate to see if I can use side angle side. So 6 match up with 12. 8 matches up with 16. Both of those are a half. So that would be, yes, again, by side angle. Ooh. Yes. Side angle, side similarity. Naming those triangles isn't so bad. ALW, ACE, if you just stay in the same order. A proof. We haven't done a proof in so long. Jamie, do you already fill the proof in? Oh. The way you were sitting over there, I figured you had all this already done. I was just going to make you do it all. I was going to go sit down. All right. The first reason, 90% of the time is what? Given. And this time is no exception. This is given. They told us FG was congruent to GH, and it's already marked in the picture. And they told us JK was congruent to KL. Okay, so it's already been marked. They also told us angle F is congruent to angle J. So let's find that here and also write that reason is also given. These two blanks, it says base angles of isosceles triangles are congruent. And it has two blanks. So we have the base angles of the first triangle, that's angle F and angle H. So we need to write that angle F is congruent to angle H. And then J is congruent to angle L. Okay, we were given F and J were congruent. So it says by the transitive property, H is congruent to J. Then they're going to use a transitive property again. So F is congruent to J. H is congruent to J. We could say F is congruent to H, but we already said that. What else is congruent here?
G is congruent to K.
G is congruent to K. Do we know that? Have we talked about those angles in here?
Well, it says that. Oh wait, never mind. Hold on.
We didn't say that just yet.
Angle L.
Angle L is congruent to what?
J.
Angle J.
Angle L is congruent to angle J. We already said that.
Oh.
F.
All right, so let's look at this. We need angle F. Give me to angle F. Angle L is congruent to angle F. We need to get to the other triangle. So now we have two angles congruent on each triangle. So we can say that they're congruent by angle similarity. You can't use side angle side without showing that the sides are proportionate, and we didn't make any statement like that. All that we said was that angles were congruent on the two different triangles. So that one is angle similarity. Whew. Proofs can be such a doozy. All right, indirect measurement is this blank. Look at me being prepared to fill in my blanks in my vocabulary words today. Indirect measurement. Indirect measurement is used anytime you're trying to measure something that you really actually can't measure. Okay, so they'll use similar triangles to measure things, perhaps like this question. Getting ready to rock climb and want to know how high the cliff is. Well, you can't really measure it if you can't get up to the top of it. So if you're wanting to know before you climb up to the top of it, you might use a similar triangle to figure it out. Okay, Darius did this. He said he wanted to know how high he'll have to climb. He places a mirror on the ground and walks backwards until he can see the top of the cliff in the mirror. What is the height of the cliff? So he has himself to the mirror. He knows that distance, and he knows how far the mirror is away from the cliff. He wants to know how tall the cliff is. Okay, this angle that he's looking into, it will be the same, it says, as the angle to the top of the cliff. So we have these proportionate sides. How can we find X? Well, I just said they're proportionate. We have 5.5 matching up with that X. And we have 6 matching up with that 34. And we can solve that proportion. You guys have shown me you're really good at solving proportions. We've got that down, 5.5 times 34 and divide by 6, right? We end up with, it says, what is the height? It doesn't say anything about rounding it. Uh-oh. So I got 187 over 6. And we can say approximate. We're talking about distance. It's approximately 31 feet if we round it to the nearest whole foot. 31.16 repeating. All right, good. On 1 through 6, I'm looking at the next problems. On 1 through 6, we don't have to say the triangle similarity statement. It just says, do we know that they're similar or not? So just checking to see if it's angle similarity, side angle side similarity, or side side similarity. Let's check these 6 problems. It shouldn't take us too long. Number 1, they mark these sides parallel. If those sides are parallel, alternate interior angles are congruent. So this one ends up being yes by angle similarity. Watch for those little arrows showing parallel lines. That gives you equal angles. Number 2, we have an angle and a side. Is that enough? Nope. We got to either have, why did I write an A? I was supposed to be an N. No, we don't know that. Okay, we either have to have 2 sides and an angle or 2 angles. Number 3, we got some parallel lines marked. So again, you end up with some congruent angles when that happens. These would be corresponding angles. These would be corresponding angles. So the big triangle is going to be congruent to that little triangle. Again, yes, by angle similarity. 2 congruent angles is enough to tell that triangles are congruent. Number 4, they already marked this vertical angle. We have 1 side marked. Is that enough information? 1 side and 1 angle. Nope. Not enough information. Number 5, we have 2 sides given their dimensions. We have an angle. So let's check and see if those sides are proportionate. 28 to 14. Is it equal to 10 to 5?
Yes.
Yeah, that'd be 2 over 1 and 2 over 1 if you reduce those. So this one is yes by side angle side similarity. Remember, you're not proving them congruent. You're proving them proportionate to one another on the sides. Proportionate. We want to make sure that they would reduce to be the same. Have that same scale factor. Number 6, we have no angles marked. We have 3 sides. Can you guys tell by looking at it?
Yes.
Why yes?
13 is half of 26 and 15 is half of 30.
Good. Excellent. Yeah, so you don't even need to write this down if you can just see that. 26 to 13, 30 to 15. Again, it's 2 to 1 or just 2. So this one again is yes, but this time by side similarity. All right. I feel like we got it. I'm not seeing a lot of deer in the headlights. We may not got it. We may need to practice it some more. If you want to finish up the rest of the notes, I'll finish it up. But I think you guys are ready to go. So I think you can just get started on the assignment. Try that. There's not a lot of problems to do. We got 1 through 6, and then only 3 multiple choice on the back of it. Look at that little assignment. I'm wondering if I didn't cut something off of there when I printed it. Oh well, my loss is your gain. 9 problems. Do pay attention to the directions it says to determine if the triangles are similar. Write a similarity statement and name the postulate. So after you say yes or no, like on number 3, if you're doing this problem, you have your 2 little triangles, L, M, N, and O, P, N. And we have these congruent corresponding angles. So I'm going to say yes by angle similarity. And then I have to state that the triangles are similar, or name them and make sure that they're named in the correct order. Now, when you look at the answer key, if they didn't list it as LMN, you're gonna need to check and see if your letters are in the same place as the other one. There's different ways you could write it, but L has to be in the same place as O, M has to be in the same place as P, and N has to be in the same place as N. So you'll have to check the order of the letters if you use the answer key. Okay, but you have to have all that information on there. It says determine if they're similar, that's a yes. The similarity statement is this, and the postulate is angle-angle similarity. Okay, so all of that is included in your answer on these first 6. All right, get started on it. Before I come around and answer questions or help any, I'm gonna go back and answer these questions on the notes page. I'm not gonna talk, I'm just gonna work them out.